AI code ships 2.74 times more vulnerabilities. 3 free tools catch it. Now, on to the AI learning.
AI-generated code carries 2.74 times the vulnerability rate of human-written code. That is not a vibe. That is Veracode and the Cloud Security Alliance, measured in 2026. And roughly 45% of AI-generated samples contain at least one vulnerability. And before anyone says it, this is not an argument against using agents. I ship agent-written code every week. It is an argument for putting a gate between the agent and production. Here is the actual problem. The agent writes faster than you can read, and it does not know your threat model. It will happily hard-code a secret in source, concatenate user input straight into a query, and import a package that does not exist. None of that is malice. It is pattern completion. Speed without a gate is just faster shipping of exploits, and the fix is not to slow the agent down. It is to make the gate automatic. Before the tools, know what you are looking for, because it is the same short list every time. Injection, where user input reaches a shell command, a database query, or an eval without ever being validated. Secrets committed to source instead of read from the environment. Missing authorization on a route that looks internal but is reachable from the open internet. An unsafe deserialization of data you did not create. 4 categories. An agent will produce all 4, confidently, with clean formatting and a helpful comment explaining what it did. 3 tools close most of the gap, and all 3 are free. Semgrep does static analysis, fast enough to run on every pull request. Gitleaks finds secrets before the commit lands, and npm audit checks your dependency tree against known vulnerabilities. Individually, they are useful. Wired as required checks and continuous integration, they become the thing that stops you shipping the mistake at all. That is a real scan. 2 files, 74 rules, and it found 5 blocking issues. User input concatenated into a shell command, user input passed to eval, and it traced the data flow from the web request all the way to that eval call, sub-second, on a pull request. This is the cheapest security you will ever buy, and the agent that wrote this code had no idea any of it was wrong. Gate 2. Gitleaks scans the working tree and the Git history, because a secret that was committed and then deleted is still in the history and still compromised. 1 commit, 121 milliseconds, 1 leak. Note the entropy score. That is how it knows a random string is a key and not a variable name. I have shipped this exact mistake. An API key sitting in a browser bundle. This check is what catches it. Gitleaks tells you a string looks like a secret. Trufflehog goes further. It scans the full Git history, and with the only verified flag, it actually calls the provider to check whether that credential is still live. That distinction matters enormously when you are triaging. 100 rejects matches is noise. 1 verified, currently working AWS key is an incident. Trufflehog also scans S3 buckets and Docker images, which is where secrets go to hide after you have cleaned up the repository. Gate 3 is the one people skip. Those are real advisory numbers against real package versions. An agent will absolutely pin for you if it learned from old training data. Server-side request forgery, credential leakage, prototype pollution, 3 vulnerabilities, 2 of them critical, in a dependency list with 3 entries. You did not write that code. You are still shipping it. Now, the threat that only exists because of AI. Models hallucinate package names. Attackers noticed. They monitor which names models invent most often, register those names on NPM and PyPI ahead of time, and wait. Your agent suggests the import, you install it, and you have executed an attacker's code. It is called Slopsquatting, and it is documented by Seth Larson, SNCC, and Palo Alto Networks. There is a nastier variant that chains it with prompt injection to make an agent install the package for you. The defense is one command. Before you install anything an agent suggested, ask the registry whether it exists. A 404 means the model made it up. And never run npm install just to find out, because installing is what executes the payload. Then pin everything to an exact version, no carets, no tildes. A floating version range is a promise that tomorrow's build might not be today's code. And here is the part that makes it real. Running these locally is a habit. Habits fail. Wire all three into continuous integration as required checks on every pull request with flags that make them exit non-zero. Now, a vulnerable merge is blocked by the pipeline instead of caught by whoever happens to be paying attention. The gate does not depend on you remembering. One detail that matters. Use audit level high on npm audit, or a noisy transitive dependency will fail every build and your team will disable the check within a week. A gate everyone routes around is worse than no gate because it produces the feeling of safety without the fact of it. One more, and it is the one people underestimate. If you are building anything that takes user input and passes it to a language model, prompt injection is your primary threat. It is ranked number 1 in the ODA-WASP top 10 for large language model applications. And the honest part, which most tutorials will not tell you, no input filter is 100% effective. You design for containment, not prevention. Least privilege on the agent, no ambient credentials, and a human gate on anything irreversible. So, add 3 questions to your threat model for anything an agent built. Did it hallucinate a dependency? Did it store a secret in source instead of an environment variable? And did it validate user input on every path that accepts input, not just the one you tested? 3 questions, 30 seconds. They catch the overwhelming majority of what these tools get wrong. If you take one thing from this, the agent is not the reviewer. It cannot audit its own output because the same model that wrote the flaw does not see it as a flaw. The gate is the reviewer, and the gate has to be code that runs whether or not anyone is watching. Write the gate once. It runs on every pull request forever, including the ones you merge at midnight without reading. The full class walks the complete hardening build. 6 verified tools including CodeQL, SnickCode, and trufflehog, the whole vulnerability taxonomy, the continuous integration gates, and the prompt injection defense chapter. It is free, there is no sign-up, and there is no paywall. 66 free classes in the DDS Vibe Academy. Link is in the description. Subscribe at DDS Boston.